Alrighty. Happy second semester. Seniors, 1 to go. 18 weeks-ish, roughly. Plus 3 right, 19 weeks, we'll call it. Not even, because you get out the last 2. Which would be down to that 17 weeks. Alright, let's go. Let's push through it. So this week, we are going to, we ended first semester with graphing sines and cosines, and the first lap wave of those. First lap meaning first spin around the unit circle. Okay. Today we're going to hit tangent and secant. Tomorrow, fingers crossed, we'll do inverse sine. Okay. Might be a weather day tomorrow. You never know. Don't want to talk about it. Okay. Might be a weather day. Friday, inverse cosine. If something happens where we don't have school one of those 2 days, then we'll adjust it and have stuff going on with that. So, yeah. All righty. Let's jump into it. So, I want to start with graphing tangent. Okay. So that's going to be our first one. So, it's going to utilize much of the same concepts, ideas, procedures, all that fun stuff of graphing sines and cosines. With the exception of, there's going to be some goofy ones in these. Okay? Because tangent is just by itself goofy. Sine and cosine, those were the 2 easy ones. Okay? So sine and cosine, remember we had those like 9 things that we always found? Domain, range, low, high, middle, start, end, period. I feel like I'm missing one. Amplitude. Missing the key one. Amplitude. Okay? So we had all those. With these, we're not going to be able to find those. Okay? Because the domain is not always going to be all real numbers. That's 4. Okay? And that's because when we're dealing with sine, possibility exists that it could be 0. When we're dealing with cosine, the possibility exists that it could be 0. And on these next 4, we're always dividing by either sine or cosine. And so the domain is not going to be all real numbers. So let's figure out those spots. So tangent here, tangent is sine over cosine. So the first thing we should figure out is where cosine is 0. Because those are no-go spots on our graph. We can't divide by 0. We're not Chuck Norris. Okay? Right? So where on the unit circle is cosine equal to 0? Oops. I don't want to say that way. I want to actually go like this. So where is cosine equal to 0 on the unit? 0. Cosine is at 0 in pi? Do we agree with that? Not a lot of people agree with it. Because on the unit circle, what is cosine? Cosine's x, right? So it's at pi over 2 and 3 pi over 2, right? Could it also be negative pi over 2? Yeah? Could it be negative 3 pi over 2? Yeah. and all the way through there, right? So the tangent function is not defined at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, all the odd pi's over 2, and all the odd negative pi's over 2. Okay? So in those spots, we have to put vertical asymptotes. Because in those spots, that function is not defined. Okay? Now, let's spin it around. Let's say instead, let's look at where sine is 0. If sine of x is equal to 0, what does our tangent fraction look like? Because it'll be 0 over some number. It'll be positive 1 or negative 1. So it'll be 0 divided by plus or minus 1, which is what? Those are all 0. Okay? So where is sine equal to 0? 0, pi, 2 pi, right? What about negative pi? Negative 2 pi. Yeah? Okay. All of those. So all of the whole pi's, our tangent function is equal to 0. Bless you. Yeah? So we could put those in. Okay? Let me ask you this question next. What is the next easiest value to find for tangent? Remembering that tangent is sine over cosine. When they're the same thing, because then tangent would be equal to 1. Okay? So where is, we'll put this one way over here. We'll go over here with it. Where is tangent equal to 1? Look. Pi over 4. And which one? Can I go plus or minus with those? Ooh. Where, I'll go around to the window. That shit's great. Black. So pi over 4 here, tangent equals 1, right? Negative pi over 4 would be down here. is tangent equal to 1 down here? No. Okay? So where again? So we had pi over there and there. Okay? I think it's not sunny. Look at. Okay? So what would this negative angle be down here? Negative 3 pi over 4. Okay? What would this negative angle be up here? So that would be here, 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 and there. And lastly, what's the next easiest value for tangent? Negative 1. So where would tangent be equal to negative 1?
Can you just put the signs of those? Like, it'd be positive or negative 5 over 4, negative 5 over 4.
3 pi over 4 and 7 pi over 4?
Yeah.
Yep. And those would be here, and here, and here, and here. Now we have enough. Just by doing the easy ones, we've got enough to graph these functions. Because this function is going to, it can't cross over a vertical asymptote. So it looks like that. So our domain would be all real numbers except plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus any odd number of pi over 2. Okay? Our range would be all real numbers, because we go on forever and ever and ever, up and down. Okay? Our middle is 0. There is no amplitude, okay, because it's going to go on and on and on forever, up and down. Okay? It doesn't have a start. It doesn't have an end. It doesn't have period, because it just keeps repeating itself. So if we were to have you graph this, we would have you graph from negative 2 pi to positive 2 pi. We'd actually do 2 laps on this. Okay? Which is what we have right there. Okay? Any questions on tangent? Good times. Good times. Okay? Let's move on to secant. Now, Zoe, just for your knowledge, because don't you have a conflict today, right? Yeah. All right, so let's hit up secant now. Secant is what? What is secant? Inverse of cosine, so 1 over cosine? So we're 1 over cosine here. Yeah? So once again, where is cosine equal to 0? Oops, let me refresh that. Let me say this way. So the secant of x is undefined if cosine of x equals 0. So where does that happen? Where does it happen? Same as the last one, right? The odd pi's over 2. Right? Okay. And what goes there then? Asymptote, vertical asymptotes. Yep. That goes. Oh, that's OCD tip. Right? Yeah. So this would be x equals negative pi over 2. X equals pi over 2. X equals 3 pi over 2. X equals negative 3 pi over 2. Okay, like it? Huh? What's the easy one for secant? Well, first off, can secant ever equal 0? Why not? Why can't secant ever equal 0? The only way a fraction's equal to 0 is if the numerator is equal to 0, right? What's the numerator in this one? 1. Okay, not 0. Can't ever be 0. Okay? So secant can never be 0. Okay? We lose that easy point. Okay? Next one. Can cosine be 1? On the unit circle, can cosine be 1? Yeah. Okay, so let's find that one. So secant is equal to 1 if cosine is equal to 1. Where is cosine equal to 1? No.
No, only odd.
No. So let's start with, is cosine equal to 1 at 0? At x equals 0. Yes, okay, so it's 0. Okay? What's the next radian measure that cosine is equal to 1? 2 pi or 360, because I said radian, not degree. Okay, so 2 pi, right? Okay, when's it next? At 4 pi. Let's go the other way. Backwards. Now, negative. When's it negatively equal to 1 again? Negative 2 pi. Next one. Negative 4 pi. Cosine is only equal to 1 right here. That's the only spot that it's equal to So that means at 0, we would be at 1. At 2 pi. So then this would be out there. Out there. Okay. Where is cosine equal to -1? Oops, I'm sorry. Let me refresh that again. Jumping ahead of myself. Where is secant equal to -1? Well, that would happen if cosine is equal to -1. Where does that happen? At odd multiples of pi, right? So plus n minus pi, plus n minus 3 pi, plus n minus 5 pi, etc. Right? Now, I'll tell you this. We have enough. If we apply some logic, we have enough right there to graph it. Because what did we say about secant being 0? Can't be, right? So it can never go like how, you remember how tangent was those waves and it went right through the middle? This middle, and I'm going to see if I can do this. Yeah, I should be able to do this. I can do this. This middle area right in here is a no-fly zone for secant. Okay? Because it's not going to be 0, so we're not going to dive down in there. Okay? That's a no-fly zone for all of the secants. Come on, work for me now. Yeah? So because we know that, our graphs are going to be parabolic. In those middles. Ooh, that's way bad on this one. Okay? And again, we would ask you to graph from -2 pi. Good stuff. Now, as we alluded to earlier, okay, so your turn now. You and you can do this on one sheet of paper, like do it on a fresh sheet of paper, because we are going to collect it from everybody. So on one side, we want you to graph cotangent from -2 pi to +2 pi. Okay, that's your domain. Minimum. Okay? If you want to go more, you go more. Okay? And then on the back side of that, or if you want to put them both on the front side, that's fine. I don't care. Okay? We want you to graph cosecant. Again, -2 pi, +2 pi. I'll make the executive decision. We're going to collect this on Tuesday, or it's due by Tuesday of next